Welcome, everyone. It's great to have you all here today. And I'm Alessandro Grande, Head of Product at Edge Impulse, and I'm really excited to be here. I was supposed to be here last year, but I missed it. So I'm really excited to be here this year and give this presentation. So today, I didn't know what to expect in terms of like the room and the audience. So I'm going to keep it basic, but I'm going to try and give you an understanding of some of the challenges that we're seeing and some of the opportunities we're seeing within the market in this exciting HML space. And I'll try to also kind of touch upon a few points that I think are really important to keep in mind when you're building applications, smart applications. Okay, so to start, I'm just going to start off with this, because I think it's important. Machine learning is not always the answer, right? And we see this a lot of times. Like, we see customers come to us and say, oh, someone has told me that I have to use machine learning for this. And then we look at it, and we look at a problem, and we realize, actually, this could be solved in a much simpler way, right? You just need a threshold. All you need is to know whether your temperature is above a certain threshold or not, right? So this is not always a solution. Although I work for a machine learning company, I tell you, I'm the first one to tell you that machine learning is not the solution. And we're the first ones to not want to really kind of put you in the wrong path, right? So it's important to keep this in mind. The next thing I'll say is, even if it is a solution, it's not a silver bullet. You have to still do work. And I like this slide to kind of try and explain the difference in engineering that needs to be done, or the kind of paradigm shift that's happening, right? So we used to code everything. We used to code rules to understand how things are behaving and express that in code, right? And then out of that, you get some outcomes. Things are changing. I mean, the really cool thing about machine learning is that you don't have to code anymore. It's not true. You still have to code, but the code is different. What you have to think about really is, how do I make the most out of my data? How do I use my data and extract valuable information out of that? In order to do that, you really need to focus on the data. And effectively, the data plus the outcomes, or the labels in machine learning terms, give you rules that you can use to understand the world around your products. Okay, so when is machine learning actually the right answer? I mean, there's multiple answers to this question, but I think today I wanted to kind of focus on three different aspects of things that you need to think about in order to answer this question. So first of all, first thing that's really important is that machine learning is a statistical method, and for that you really need to make sure that you have your business outcomes defined well before you start. Because at the end of the day, you're going to get a model that's going to tell you 95% of the time, I'm certain that this is a dog. Is that good enough? I don't know. It depends on your business outcome, on your business goal. It depends on what you're actually trying to improve, what cost reduction you're trying to hit. So it's really important to think about the problem, not from a machine learning point of view, but from an actual kind of business point of view, right? So like, what is it that you're trying to solve for, and what is the best technique for that? Rather than, we hear a lot of, I don't know if you've ever been in a meeting when someone says, I want to use YOLO V5. And like, why? Like, what are you trying to do, right? That's the problem. Like, that's the real question you should be asking yourselves is, what is it that I'm trying to solve for, right? And then the next question is, okay, how can I do that, right? Is machine learning the right answer? The next bit is, I touched on that in the previous slide. Data is really the key here. Building a good quality data set, having data that's valuable, that's meaningful, is important. And this is hard. This is where we see actually most of the people that we're working with struggle. It's hard to find the right data. It's hard to get it off the devices. Usually devices have got different sensors, so which sensor do I focus on? Which sensor do I use for my application? These are all questions that you need to answer. So really kind of having a data-first approach is important, because you need to answer those questions early, so that then you can kind of focus on developing the best model, improving it over time, and so on. The last point is around actually that improvement over time. So you really have to keep in mind that machine learning is not a silver bullet. Machine learning is not something that you deploy once and you forget about it. Like, it's not, it's not something that you build and you're done. It's something that you improve. So you really need to think about what we call active learning You need to think about, how do I improve my model over time with more quality data? I'm going to definitely collect more quality data over time. How do I use that data to improve my model? Data. There's a lot of data in the world. And when you're trying to build your application, when you're trying to build your solution, you have to think about, what data should I use and how? Like, what should I extract out of this data? What is the right sensor? What is the right label that I should attribute to this data? I mean, having something like this, right, coming in from your sensor doesn't tell you what that is. You need to label that in some way, right? And sometimes it can be really hard, especially, and I'll touch on this later, but when you're trying to simplify the problem, maybe using a simpler sensor for detecting something that's actually complex to detect, you have to label that somehow. And what you're seeing usually doesn't tell you what that is. So you need to have another way of labeling, and I'll touch on that later. And then the other thing is, I mean, the real world is giving us a lot of data, right? A typical microphone is producing about 16,000 samples per second. Down here you see a typical, using it the wrong way. No. Oh well. Down here you see a typical accelerometer, industrial grade accelerometer, that's producing about 3,000 samples per second, right? So that's a lot of data that you're getting in. And making sense of that data is not simple. Labeling it is not simple. So there's a lot of things that you really need to think about. And what we've done for many years is, okay, yeah, we'll just send it to the cloud, and then we'll deal with it. And what we've realized is actually 90% of the data, over 90% of the data, is actually thrown away. Nobody ever looks at that data anymore, because once it's in the cloud, you have no clue where it's come from, you have no clue what to do with it. It's really hard to turn it into something that's actually valuable once you've got a huge amount of data that you've never labeled. So this is all to say that actually maybe there's something else that we can do. Maybe there's some solution that we can deploy on the edge itself that can detect things out of that data, or that they can extract insight from that data and tell us something about the system and give us some answers, some insights that we're looking for. So here you see some of the reasons why that makes sense. I think for me, like one of the main ones is really around like cost saving, right? There's a lot of cost that goes into shipping data around, paying for cloud storage, having actually more complex systems that need radio, for example, and more complex radios, they need more connectivity. And with that goes bandwidth and latency. So having something that can be real time and that can be reliable is actually hard, right? Because if you send your data to a cloud and you expect an answer back, even if you do have an algorithm that's running in the cloud and that's giving you insights, you might not get that real time, right? That insight real time. So how do you get that? If you're looking for insights real time, what do you do? Well, what if you put a device down closer to the sensors and you have some of that machine learning running on these devices? So again, a lot of data, but if you can process that data on the device as close as the sensor as possible, you can extract some meaningful insights that then you can either send to the cloud, to a dashboard. You could ping on a cell phone to someone that needs to know that the room is on fire. I don't know, whatever it might be. So you can do whatever you want with those insights, and they're much less than the bandwidth is much less than the bandwidth that was coming from the sensors. So you're compressing. I like to also kind of think about machine learning as a compressing algorithm effectively. You're able to compress a lot of data into something that's much more condensed than what you started with. So what are some of the use cases that we're seeing? I mean, what I've talked about can be applied to anything, right? So it's, as a company, as a person, I like to focus. And we started looking at, okay, what is it that can actually drive the most value? And we've realized in the last year and a half, actually, that there's two use cases that are actually very valuable. And they're vague on purpose because actually I'll touch on some more of the use cases, but effectively it's what we like to call human health and machine health. The reason for this, I think it's simple, is those assets are expensive and are worthwhile looking after, right? one is your body, our bodies, and one is machines that cost millions of dollars in factories and in production lines. And making sure that those production lines, continue to work over time is important and saves us a lot of money. So those two are the main use cases I'll talk about today, and I'll dive into a little bit deeper in a second. Another kind of variable to think about is, okay, we talked about putting more processing on the edge, but what is an edge? What is an edge device? How do you define that, right? What capabilities does the device have on the edge? Here there's a bit of an overview of different types of applications related to different types of devices. So you can see that you can go from ultra low power devices that are around the milliwatt of power to GPUs that are obviously way more powerful and way more power hungry. But at the end of the day, it all boils down to what is the business problem that you're trying to solve, right? And the hardware is effectively a solution to that, right? So given the constraints you might have, the cost savings you might be looking for, the type of connectivity that you need, you might look for a different type of device. And with that, there's also the question of what sensor should I use, right? Obviously, it depends on the use case. I'm not telling you anything new here, but it's really important to understand that you have a wide choice here, right? And you need to find solutions that can scale because you don't know what you're going to be needing tomorrow, right? So today you might be starting off with an accelerometer. What if tomorrow you realize that your microphone is actually giving you a lot of interesting insights? How do I take advantage of that? Okay, so I mentioned machine health. I think this is really, really exciting because we're seeing a lot of companies actually wanting to adopt this, right? And we're not the only ones seeing this. I mean, Gartner just published something recently saying that by 2025, there will be 95% of new industrial IT deployments that will include AI at the edge, up from less than 25% in 2021, right? So this is huge. It's a huge market. There's a huge need for it because the cost savings that we can help with are actually big, impressive. And here's some of the kind of use cases and some of the reasons why this is important. I think the main thing is really thinking about if I can allow a customer to forecast their maintenance cycles more accurately, I'm saving them a lot of money. Because effectively, think about right now what is happening in a lot of cases is you have maintenance teams that go around factory floors all over every time without any way of knowing which machines are more likely to break, right? So they'll just go around in cycles, right? Without having any way of optimizing that process. If you're able to say, I'm 90% with 90% of accuracy, I believe that this machine is likely to break in the next 2 months, would you send someone to check it? Yes, you would, right? So the whole point here is, can we give insights on when machines are about to break, and can that optimize the maintenance cycles and reduce effectively unplanned downtime, right? Because that's what you want in the end is you don't want something to break. One, because it might be very expensive to replace, and it might actually stop you from producing whatever you're producing, right? And it might not be you, but it might be your customers, right? So that's definitely one interesting use case. And in the same kind of industrial space, obviously there's a lot of robots, right? We're seeing it with automotive. We're seeing with any kind of industrial manufacturing. There's more and more robots. And some of these robots are complex and very hard to monitor. And it's really hard to monitor, one, whether they're actually doing what they're doing in the correct way, right? Two, whether they are having any interactions with humans that they shouldn't be having. And by that, I mean, you need to, for example, there's some robots that are quite complex and quite heavy and potentially harmful. So you need to make sure that you shut them down if someone gets close to them, right? So you need to know if there's anything in the vicinity that could be harmed by the robot. But also you need to know whether the robot itself is going to break. So for that, there's, again, a lot of sensors. We've done a project with Ready Robotics. They're an OS provider for robotics. with Baluf, one of the leader in industrial sensors, and we basically said, what happens if you put together an external sensor with the sensors within the robot itself? What are you able to monitor? And we've realized that really quickly you're able to spin up a solution that can monitor the falls in a robot, right? So we had some robots that we were able to measure anomalies on very quickly. And again, this goes back to something I touched upon at the beginning, but here I wanted to give you a bit more details. You really think about, when you think about your application building, your development of the application, you should think about the data, right? So the collect up here, you should think about, how do I collect my data? How do I design my model? How do I test it, right? Because you don't want to put it in production before you've tested it properly, and we all know that that's something we need to do. And then you deploy it, right? But that's not the end, right? The value comes over time, right? And the thing you need to think about is, how do I build this system that allows me to improve my model over time and detect more faults, more complex faults. Another interesting use case we've developed with Isoelectro, a provider of effectively power lines in East Europe, is actually power line failure monitoring. Again, predictive maintenance on power lines. What's interesting here is that, going back to some of the reasons why you would think about doing things on the edge, we've managed to deploy a device using NB-IoT that has 20 years of battery life in the field, right? And this is something that you cannot achieve if you had your radio on all the time sending data somewhere else. So this is an interesting use case that has a lot of real value for this company that's trying to detect fires, breakages, and go fix things that might be far away from the center where they're based. Another one is industrial quality control. I like the L, how it came out. There is, we talked about the different types of hardware devices. This is a partnership we had with Lexmark. We all know them for printers. So here you see the printers being built and being in production. What they're doing now is actually they're deploying gateways in industrial settings to enable things like quality control. So is my printer, in this case, of the right quality? Does it have the sticker that I should have on? Does it have the right branding? Whatever it might be, right? This is really interesting. We're doing, obviously, vision here. So this is much more complex. It requires an NVIDIA GPU, right? Again, the span of applications are huge and very interesting. They can be very different from each other. I'll touch on this a bit later as well, but we've started seeing patterns, right? We've started seeing how really there is value in providing a starting point for companies that are wanting to develop something themselves, right? So we thought about, what if we build a box that we can provide to our customers to actually enable them to go to product faster, to market faster. This is just a reference design, so it's not meant to be something that anybody would go to market with. But we're seeing a lot of interest, and we're seeing actually a lot of adoption of our platform, our solution, based on this, because actually we can show the value really quickly, right? And some of you might have customers that need to see this. One of the challenge is that the market is still early. We probably all know this in the room. And a lot of people are still questioning whether ML is possible, whether it's the right thing, whether it's doable, whether it will actually add any value to my system. So this is something that we're doing to accelerate that understanding and that education. Okay, so now the second use case that I mentioned earlier, human health. Again, we are one of the most valuable assets anywhere. So we want to make sure that we maintain ourselves healthy. And by human health, what we mean is not so much medical devices, but devices that can help you live a healthier life, right? So think about smart watches, smart rings, or any other types of devices that allow you to, for example, detect falls on elderly people. Those sorts of devices, right? there's a huge market, there's a huge request. And one of the things that's interesting in this market is that in the previous market that I mentioned, so machine health, there's a lot of old and big players, right, that have been doing things for many years and are kind of set in their ways and are trying to innovate. This is a market where actually everything is coming out new, right? So there's a lot of high growth startups that are accelerating their developments, are accelerating their deployments, and are doing some really, really interesting things, and I'll touch on some of them now. So the first one is one of our earliest customers, actually, Aura. I don't know how many of you know of the Aura ring, but it's a wearable device. It's a ring that has a number of sensors that's able to detect sleep quality, right? So it's able to detect your sleep patterns and tell you how energetic you are given, or how energetic you're going to be given your sleep quality, right? The sleep quality that you had the previous nights and maybe on the nights before. The interesting thing about this is that we worked with them to develop these algorithms, and what I touched upon at the beginning is important here. So the data coming from the Aura ring, right, it's hard to label. I mean, these are sensors that are very basic, right, in any sense. Being able to know whether that sensor is telling you whether someone has slept well, whether they were in the REM phase or whatever other thing you're trying to detect, is hard. It's actually impossible. The only way to do it is to have reference data come through another sensor, right? So, for example, in the clinical studies, companies like Aura put electrodes on people's heads for days, for months, to try and detect how they're sleeping and correlate that data to the data that's coming from the simple sensor, right? And the reason why they do that is because that's the only way you can label the simple sensor data, right? So what you're doing is actually condensing something very complex in a simple system. But to do that, you need a lot more information than you would need if you were using the more sophisticated sensors, right? So it's a hard problem. And that's where I go back to the fact that this stuff is not easy, right? Like, we are making it easier, but it's still not easy. So, I mean, anybody thinking of doing these things, there's work for everyone because these are really complex problems. They managed to, after a year of work together, they managed to achieve actually 79% sleep scoring. The way they used to do it in advance and the way the other companies did it before was actually through manual sleep scoring. So people looking at data and going through it and saying, this is how well this person slept and so on, right? Obviously that doesn't scale, but also there's no way of giving real-time feedback if you have just that. We've managed to reach 79% of sleep scoring accuracy, and it was only a couple of percentages below the manual sleep scoring, right? So, well, good enough for an application that's not a medical device, but a health device. Another interesting one is a Dutch company called No Watch, developing actually a watch that's not a watch. So what they're developing is actually a mental well-being device or a mental well-being monitor that's able to detect multiple data coming from your body. So look at the number of sensors here. So they've managed to detect the way you're breathing, the heart rate, temperature, movement, blood oxygen, but also cortisol. This is really interesting because these are sensors that are hard to correlate because they're all of different types and they provide different type of data. So the challenge here is really, how do you do sensor fusion on these types on a series of these sensors? And how do you extract the right features from these sensors? And No Watch is, their watch is out. This works. Although it's difficult, they're doing it, right? So with this, I'm trying to say that things are difficult, but they're doable, right? And there are companies out there that are doing it. Another very interesting one is No Labs. They've developed a non-invasive glucose monitoring system. What's interesting about this is that not only it allows you to detect glucose in a body, it also does it on a handheld device, right? So we go back to the different types of business problems, to the different types of constraints that you might have. obviously this cannot have a GPU inside, right? You need to do it with a low power, low cost MCU, or maybe something a bit more complex than that, but still something that's very, very constrained. So you need to be clever in the way you build your machine learning system. And again, even for this, I'm not going to dwell into this too much, but we have worked with Sentient, Nordic, and TestSolve to build actually a reference design to accelerate time to market. Okay, now the interesting stuff. So I've touched upon this a little bit, but I don't know how many of you, actually, raise your hands if you're building things in the health space. Anyone? Okay. So you can tell me if stand up if you don't agree with this. So the big problem here is not the machine learning. The big problem here is that you have a lot of data coming from a lot of sensors, and you have to correlate that data. You have to be able to know whether the data from your wearable device, the one that you're trying to build your model for, is actually providing you data that's coming from someone that's sleeping, from someone that's awake, from someone that's in a good mental state, in a bad mental state. What does that mean, right? I mean, we saw the amount of sensors available to some of these devices. So what do you need? You actually need reference clinical data that you see down there, right? And in some cases, you also have researchers that are, as I said before, with electrodes or putting electrodes on people's heads, doing clinical studies, and seeing them run, seeing them sleep, whatever the application might be. And these people need to add data to the system so that then someone can build the model, right? So that's a lot of data coming from a lot of different sources. What we see as one of the most difficult parts is actually how do you aggregate that data, how do you correlate that data, and how do you use that data, the researcher data, the reference clinical data, to label as ground truth for your wearable device data, right? You need infrastructure for that, right? And you know, some of you might have looked at Edge Impulse before. We are a nice UI, but that's not what we are. I mean, that's what we do to like get people kind of hooked on and get people started. But really, that's not the core, right? The core is API driven. And actually, the core is an infrastructure that allows you to make sense of a lot of data of different types. So once you've done that, once you've correlated all that data, you still have to develop your model, right? Yeah, we can help you with that. But again, that's not the important piece. The important piece is you have to think about how do I make this system, this infrastructure, that maybe you're building yourself, maybe you're using a third-party library or a third-party tool, or maybe you're using Edge Impulse. How do you make that into something that can improve your model over time? How do you build an infrastructure that can allow you to improve your model? And then the last bit here is around performance monitoring, right? So you got things in the field, right? And actually, this also works in your clinical study, in your clinical trials. You might have to know or label effectively specific states of a person, of data coming in, because maybe you've seen something you've never seen before. So you wanna make sure that you annotate that, and perhaps you filter out some of the data that you actually you've already seen, that you've already been using to train your model. So this is really important. You need to think about like, how do I monitor performance of my device, of my model, and how do I feed the right data back with the right labels? Okay, so let's move now to an even more complex problem. So how do I deploy this in the field if I'm thinking about machine health? Machine health now, not human health. And what is important for the end customer, right? So we've started by saying, yeah, we can develop all this, right? And then we started getting people come back and say, actually, we don't care about that. What we care about is, I've got this dashboard somewhere, and I want you to tell me whether my machine broke, right? I mean, we are here, right? So how do we do that? Well, we have partnerships. We have all sorts of partnerships that can allow you to effectively build a system that can automate and improve the model over time, but that can also connect with an IoT platform and provide value or provide insights to maybe a factory manager or business intelligence person in the company on a dashboard, on some sort of infrastructure. But then there's also the other interesting part here. So in some cases, you might not want to deploy to your edge device right away, to your endpoint. You might actually want to go through a gateway, right? How do you do that? Well, that's the whole other series of issues. I mean, I think most people here are familiar with IoT, so this is the typical IoT problem, right? That nobody has solved yet. So if you've got a solution that works at scale, let me know. But in general, I mean, these are all things that you should think about. These are all things that your customers or the people building these systems think about. So it's really important to kind of put into perspective that we don't solve the whole thing, right? We are a component of that solution. But in general, ML is not the solution, right? ML is a piece of the puzzle. That's fundamental, but still a piece of the puzzle. Okay, I should have done this earlier, actually. Disclaimer, I work for Edge Impulse. What I'm going to tell you from now on is biased. We've got a platform, right? If you've not seen it yet, go check it out. It's a beautiful UI. You can do a lot of stuff very fast. And then, as I mentioned earlier, there's a lot of infrastructure beneath that. So there's a lot of things that you can do that are much more complex that you might not get to see right away, to experience right away. But believe me, that's where the customers are, right? Like, that's where we're getting money. That's why people are still paying us, because we provide that value. And this is just to kind of put into perspective and simplify the process that I mentioned earlier, the active learning pipeline, right? So what you really need to think about is my edge device somewhere in the field is going to share data, is going to send data at some point because my performance monitoring system is telling me that something has broke. I'm seeing something I've never seen before. Something has changed. So I want to send that data and upload it to a cloud bucket somewhere. What we do is we look at the cloud bucket. We're able to see when new data comes in and automatically retrain the pipeline that you've built. So we're automatically retraining the model that you've developed already with the new data that came in. We provide a webhook at the end. So effectively, we send a notification to you, and you can grab the model and deploy it, test it, do whatever you want with it. We don't do the CI/CD, right? That's on you. That's on your customers. We provide a way for you to automatically improve these models over time. A few things I wanted to touch on really quickly because we're out of time. Mention data, right? So we've got a lot of features to help you build better data sets. So this is one of them, Data Explorer. It allows you to look at embeddings of your model. So if you built a model, you're able to look inside the model, and you're able to look at how is the model seeing things. And you can see that there's clusters here, right? So my model is seeing that things are clustered, separated, and that usually means that my model is working well, right? If I can cluster things in an easy way, my model is behaving well or is understanding things well. Now, you can also see that there's some samples there that are labeled as this cluster, right away. And you can say, oh, let me look at that sample. What is that? Well, that's a yes, but actually that should be noise. Oh, there's something wrong here. Either my model is wrong or I've mislabeled my data. So these tools allow you to quickly iterate over your data set and make it better. We've got AutoML. I'm not going to get into this. But one thing I want to just say is AutoML is not useful unless you also think about the DSP, right? We're all embedded and IoT folks here. We know that DSP is half of the problem, right? So we do automation of machine learning and DSP together. That's why I gave you the disclaimer, because I'm talking about Edge Impulse way more now. Okay, and then last bit is we're able to do a lot of testing on the platform to allow you to have more confidence before you deploy to production. So you can do up to 24 hours worth of testing of your application with 24 hours worth of data on the platform without having to move it to actually deploy on device. We've got simulation running in the backend that can tell you how well your performance or your model is performing on the real device, latency, memory, and so on. Okay, just to end, I want to stress three things. Make sure you are clear on what your business outcomes are, because otherwise you'll never finish. I mean, that's the problem, right? If you don't have clear business outcomes, you can go on forever. You'll never come up with a product. Second, focus on generating insights reliably and early. So think about how can I shift some of the computing earlier in the process because that's a lot of value. And third thing is, think about your active learning strategy. We can help. But aside from us, even if you're doing it yourself, think about that, because that's where the value is. A single model that runs today has no value. What has value is the infrastructure you build or the infrastructure you use to make the model better. Thank you.
We have 1:40. If there is any question.
One question. Anybody has any questions?
Yeah, just picking up on your 95% stat of new devices. So for the sort of legacy sensors that are out there, how do you think EdgeML is being brought to that? Is there a sort of modular EdgeML approach, or just replacing the sensors, or something else?
No, we do a lot of brownfield deployments as well. So we deploy to a lot of, when you say sensor, we need to understand if there is a CPU processing unit by the sensor, right? Otherwise, depending, in a lot of cases, what companies are doing, or they were doing, is send data to maybe a gateway in the factory floor, for example, on the factory floor. So in that case, you could do the computing on the gateway if you're not able to do it on the device, but it's still closer to the sensor itself, right? So the point is, how close can you move it, right? And nowadays there's sensors coming out with actual compute power on the sensor itself, right? Obviously they're constrained, even more constrained than the MCUs that we're used to, but it's all about getting as close as possible to the data.